the 6:30. On the left hand side, there will be your participation details like general detail, profile, FDP, applied FTP, attendance, and then there is a section called assessment. You have to click on the assessment and you will see the FTP's test. On the right hand side, there will be a test link that will be enabled at 6:30 p.m. sharp and it will get disabled at 7:30 p.m. sharp. So ensures that you are giving the examination during this time. Remember that this portal is handled by AICTE, not by the coordinator of the FDP. So later on the request of giving the examination, we cannot help you out on that. So please ensure that you are giving the examination during this time only. So before 6:30, you can just try to log in onto the portal and find out where you need to give the examination. Thank you. For any queries, you can reach to either Dr. Dipesh Kamdar or the Dr. Jignesh Joshi on the WhatsApp also. Thank you all. Over to you, sir.
Thank you, sir. And actually, we believe that we have fired the test at 6:30, so it will be visible from 6:30. If the test is not visible, then later we will conduct the test by using some other thing, and we will inform you with a mail if something is not there between 6:30 to 7:30, because we will came to know at 6:30 about the assessment test. So be here within some 2-3 minutes. Mr. Nilesh Ranpura will be here for the next session, AI ML in semiconductor. Yes, welcome Nilesh Ranpura sir, E-Info Chips and Aero Company.
Hello, good afternoon, everyone, and highly appreciate you team joining on the Saturday. It gives me immense pleasure to see that all of you are hungry and resonant to gain the knowledge. Let me share my screen.
1 minute, sir. Just give me 2 minutes to introduce you. So, welcome all in day 6, session 2, AI ML in semiconductor. Mr. Nilesh Ranpura sir. He is a senior director engineering semiconductor. He is having a 25 years of industry experience in driving, leading, and executing semiconductor products in the area of data center, high-end networking, IoT, mobility, consumer, healthcare, and automotive. Architecting VE, design IP, design for test and physical design for projects, and extensive working experience in Silicon Valley, USA, Europe, Israel, and Japan. uh, with a strong execution towards performance evolution, cross-functioning teams, a turnkey execution ITL2 GDSII ASIC semiconductor parts, and driving a goal of organization. He wrote a 10 plus international papers. He received a BE from DDU, ME from NIT, and MBA from IIM. So actually, as I know about Nilesh sir and eInfochips, they believe in an ecosystem where they are always ready to help a society. If we talk about academia and institute, then they made open door for all type of services for the development of faculties and student. We as a VVP are very well connected with them from last more than 10 years for industrial visit, faculty development programs, skill development programs and workshops for the student, mock interviews and TPO meet as well as campus drive. So with the esteemed support of eInfochips, we have invited Nilesh sir for the FDP, and particular this session, the session was suggested by himself that this is a totally new thing and all faculty will love this. So welcome, sir.
Thank you. Thank you very much, Dr. Jignesh and VVP team. Okay, so today's my topic is AI, the impact of AI on human life and how it is correlated to semiconductor. So my presentation can be interrupted anytime during the session, and I'll be happy to answer that. So, how do you see the upcoming applications and ideas and the products which is touching our life? And that's a very small question, but you'll see an interesting answers coming up. You might have seen this kind of application on videos or presentations, kind of self-driving cars, where the reinforcement learning is strongly imbibed in the autonomous vehicle, which can drive the road safely and navigate the road safely. This is an actual view of, a window of an autonomous car and how it is detecting objects, humans, vehicles, etc. And the same application you might have seen in the dashboard of the car, how it looks like, the sensors view, the cameras view, the lidar and radar. This is one of the strong application emerge only and only because of AI. You may wonder why. So initially, when Tesla was developing this kind of self-driving car, and we know because we were developing silicon chips for them, Tesla set up world's first AI unit, AI business unit, and they hired 500 plus experts doing AI activity and developing AI-based semiconductor chips and software both. And that's the reason they are very much ahead into autonomous car development or EV car or digitized car. The foundation of that car is AI engine. Later on, they dismantled the AI group and they converted the group into autonomous car group. This is one of the strong applications. This you all have seen language translation, where a human can translate the language from body language or gesture-based language into symbol, and this can translate what it tries to write. For example, hello word or any other meaningful words. This is very basic view of AI application. Financial analysis, the financial sector is highly gained momentum because of AI. You have transaction details, you have framework of the financial infrastructure details, and you can do a fraud detection very, very strongly through AI mechanism. Gaming. We have seen chess as a very common game in the computer graphics, in computer algorithms. They implemented the level 1 of AI 10 years back. In robo and human playing games like chess and more, they are strongly implementing AI, predictive AI, to understand the whole gaming functionality. These are the sample examples of AI and its application. Of course, when we go to consumer, there are many more: virtual reality, voice-enabled assistants, face recognitions, processing of the images, etc. You all have seen and heard the healthcare domain is flooded by AI's application, like generative AI in healthcare has gained the highest momentum across the world. GPTs, Bloom, Deep Dreams, Dell, Stable Diffusion, Whispers, and many more platforms has been implemented in generative AI, and all of them are addressing four common areas: medical imaging, drug discovery, personalized medicine, and population health management. This is the biggest area, one of the biggest area after autonomous driving in AI. The next 10 years of healthcare will have AI a very strong foundation. We as a corporate are also working in the same domain because it's a larger set of business and impact in the human life. Recently, cybersecurity itself has been come up as a new feature or a new application where AI has been implemented to detect anomalies, threats in real time, and understanding and protecting digital assets. The benefit is it's faster, very, very fast, and it detects fraud versus real fraud. Most of you have seen Uber or Ola. This is the best example of AI-enabled engine. Everything you see on the Uber or Ola, or to be matter of fact, now on Swiggy, is enabled by AI engine. It starts with the stage one login itself. The moment you enter the phone number, it starts predicting many things. Then it goes into your detection of your current rides, past rides, captures the data, brings the data, and it moves on to the next stage, etc. The smartest algorithm is implemented into rider and driver matching based on the past history, based on the location, based on the location customers, based on the number of car, based on the number of customers, and there are 11 parameters defined by Uber's software team ensures that the AI meets the right rider and driver. And of course, then the payment part. This is a 11-stage Uber AI engine, highly implemented on software, executed on GPUs. What is the engine behind AI? AI is behind many things, but what is the engine behind AI? And the natural answer we all have is ChatGPT or ChatGPT style of structure. Of course, as a common knowledge, the company OpenAI created the ChatGPT, natural language processing, using this technology and a model, both. And it worked out as a master stroke for most of the application. So NLP model and GPT are the strongest foundation behind AI. And if you do remember, this is the best diagram to remember always for the AI. The engine behind AI is these three circles. The core engine is always deep learning, which has complex algorithms, including deep neural nets to train the model. Then on top of it, you have one more circle, machine learning, which allows system to automatically learn and improve from the experience. So here is what you'll see: algorithm, formulas, mathematics, and many more things. Here you will see a system, a framework, a stage-wise, behavioral models which will learn, upgrade, run. And then of course you have third layer, which is AI, which is the ability to imitate the behaviors. based on these two circles. This is a very simple way of understanding AI. Now, the reason to show it here is semiconductor industry, hardware industry, systems industry is trying to have this as much as into the hardware and put only thin layer onto the software. So for example, the orange circle and the green circle can go up to easily 50 to 80% on hardware. That means it can go into silicon. The light blue version can go into a software, or it can also go into hardware and software combined. The more of this circle goes into the hardware, the more the faster responses will be. And AI has to be faster. If it is not faster, then it's not called AI. Then you can call it as manual machines. So that's where we are entering now, that the more and more circle has to be packed inside the hardware engine, and the hardware engine goes inside silicon. What is behind this engine of AI? Most of the AI chatbots or even chat GPTs or any other Gemini platform, they are running on a set of processing engine. Some call it GPU, some call it DPU, some call it any name, but they are architected as a components which are highly interconnected. So any silicon inside GPU or any silicon inside such architecture will have multiple processing blocks like a green blocks. It's called AI engine, and it is connected internally through a memory. So it does data in, data out, copy, and it is connected for parallel processing with other engines. If you see, it is having a high-end vector processor, a very large scale, instruction word set processors, and then they are connected to a memory, gigabytes of memory, and then it is interconnected with other processing block. So you can call it multi-core CPUs with high speed memory, high capacity memory. This is one of the basic building block of AI. And that is the reason AI engines are becoming more and more faster, because you can put every formula into a processing engine in parallel, and you can run multiple formulas or multiple algorithms or a single algorithm textured into multiple CPUs and make it faster and make it more predictable. This is the hardware architecture of engine behind AI. To give an example, GPU is the most common word everybody is talking about. This is developed by multiple companies, but it's a very crucial component. GPUs are like CPUs only, central processing unit, but they run a lot of things in parallel. And that helps AI to run the algorithm parallelly. They're very efficient because they're all working at 1 gigahertz, 1.5 gigahertz, and 2.5 gigahertz, high speed. And they're flexible because they are having multiple GPUs on one board or one silicon die. So if you reduce the performance, you can reduce the number of CPUs and GPUs. Or if one GPU or one CPU fails, everything doesn't fail. So this increases the flexibility. And that's why GPUs are getting popular, because they are highly flexible, they're highly high speed, they're highly performance oriented, which is not common in normal processing engines of PC or laptops. Like in laptop, you will never have number of processors so much configurable. When you buy the laptop, you will have quad core, 8 core, hexa core, and that's it. If you go above that, the cost goes like anything. Well, in GPU, it is minimum is 100 core. There are multiple companies making GPUs. NVIDIA is a known company as biggest company, followed by AMD, Advanced Micro Devices. They have recently launched multiple GPUs in last 2 years. Then came Intel, and Intel is able to do fairly good, but they are lagging into the market. Qualcomm has introduced Snapdragon processors, which are also creating a foundation of GPU and enabling AI on mobile devices. So when you run Uber or when you run Swiggy engines, Your mobile will process it on Snapdragon quad-core, hex-core, octa-core processor and runs it very efficiently. Same for photo processing. And of course, ARM has launched Mali series of GPU. So GPU and similar architecture called DPU are the foundation of AI engine to run it more efficiently, fastly, and predictably. If there were no GPU or no DPU, AI could be very, very small engine or a slow engine, and it could be just like any other embedded software which runs during neural network processing or during normal processing. Here is an example of three major companies, NVIDIA, and you can see in last few years how their GPU semiconductor has increased the market share and is reaching to $10 billion. AMD started less, but they are reaching up to $1.3 billion market cap. Intel is also going the same way. So it is not decreasing. The more and more applications emerges, like mobility, consumer, healthcare, the need for DPU is going to increase exponentially. And now data center growth has done this exactly same in engines behind AI. As an industry, we are seeing a strong trends that AI ML based computing chips are going to rule the world. Last 2 years, most of the semiconductor companies, including us, are doing AI enabled chips for IoT, for consumer devices, for 5G data center and networking and robotics application. All of these four applications are heavily being used, including AI-based chips. Of course, when we do this, it will give excitement because it does all functionality of AI. But the challenge is it is a multi-core design, so it's a complex design. Multi-core design requires special design skills, challenges coming, and it also needs high-speed interfaces. It also has stringent power, performance, and area requirement. So designing AI ML chip is a complex function now, but at the same time, industry is having trend to do more and more silicon for AI. These challenges are going to increase and not decrease. And when the challenge increases, the outcome is very simple. We need more people, more engineers to solve the problem. And hence we go and hire more people from academia. This is the most recent semiconductor chips we have made for world's leading company in a search engine area. This is for Google. There are 3 ASICs we taped out. Actually, there are 11 ASICs we taped out. This is a top view of the board, which is having AI engine in the silicon. This is a top view of the silicon die. On the die, they have kept heat sink, metal heat sinks. From the side view, the metal heat sinks looks like this. And the silicon is here, very, very small one. But the heat sinks are so larger that it looks bigger. The reason is this single ASIC consumes 600-watt power, 400-watt power, 500-watt power, which is very, very uncommon when you open any PCB. Generally, PCBs consume 0.3 watt or 1 watt at the max. Here, it consumes 400 watt. So it's like a 2, 3 electric bulb which are live. And when you touch it, it's very, very hot. So we need larger heat sinks and we need liquid cooled heat sinks instead of air cooled heat sinks to cool down the chip. And then this kind of multiple boards are fitted inside this rack or data center rack. And then that's how data center works for Google or any other similar company. Data centers consumes highest power, highest speed, highest memory, and highest number of AI-enabled silicon. So this is actual Google's data center on which we tested our chips. And this is the board having the 4 chips, and all of them are AI-enabled chips. But it's very interesting to see that Google is developing silicon chips. Well, Google is actually a search engine company and not a semiconductor company. But it is important for Google to design that, because if they don't design, they will rely on other side or other party who is not able to design as per the Google's requirement. So Google is creating their own semiconductor ecosystem to design AI-based chips for AI-based hardware platforms. We have worked with a very recent startup which has created similarly DPUs. It's called DPU, just like a GPU. It's a digital processing unit, but the architecture and structure is exactly same. It has 1,000 core on the chip, and it is interfacing with HBM, high bandwidth memory, multiple high-speed Ethernet network, just like any other building block of AI. And it consumes 600 watt or even 700 watt power as a single die. This is one of the complex chip, highly security driven chip for AI, which we have developed for American customer. So this are run inside the data center. So this is an actual data center, AI data center, having chips from them, and they are basically running it here. A lot of Indian companies bought this data center and they are running it their own solution, and they're getting AI features and AI supports when they use this chip. Now, the market is coming up with the second generation of semiconductor chips for AI. Microsoft Azure or Microsoft Cloud Department has launched Maya 100, which is Microsoft's first chip having artificial intelligence features inbuilt inside the chip, and it will make Microsoft independent and not dependent on NVIDIA. This was a very major shift happened where Microsoft wanted to enter and design AI chips. Microsoft is a traditionally software company and never semiconductor company. But this news or this strategy looks very prevalent that the larger players like Microsoft, like Google, like many of the company, Amazon, they want to develop their own framework and ecosystem for hardware. And as a part of that, they are doing their own silicon design or semiconductor chips. What if they don't do? If they don't do, they have to always rely on NVIDIA, and NVIDIA will become monopolistic in the AI market. Nobody wants AI to be monopolistic market, so everybody wants to offer a solution by their own way, or multiple people wants to offer a multiple solution so that the AI's market doesn't remain monopolized. And that's a fair thing. So last year, Microsoft was a major player who entered the AI market, but developing AI chips, that was their main criteria of entering that. And of course, before 2 years, they acquired OpenAI, which is ChatGPT owner. So now you can see Microsoft has OpenAI, and they have hardware platform called Maya. So they have hardware, they have software, and they can lead the world and they can compete the NVIDIA GPU. Me and my team have been working on this chip for last 1.5 years, and we have tested the Chat GPT engine on this silicon running very fast, and of course many other engines as well. This is an idea to give an understanding that wherever there is AI, the half of the component is semiconductor which is running the AI, or the algorithm which are being implemented into the hardware for AI. How do we see if we extrapolate this semiconductor and AI in the next future? So the world of semiconductor or AI in semiconductor is increasing linearly. It is going to reach approximate $230 billion market, which is like 10 times in the current market. That's the scope of AI-based silicon or AI and semiconductor market. Big market. If Microsoft enters, if Google enters, if NVIDIA already is there, 10 more companies will enter. Just to share news, Ola Electric, Ola two-wheeler make, they already have set up their own AI silicon team in Bangalore called Kutrim, and they are working on India's own AI semiconductor chip, which can run Kutrim. We foresee as an industry newer application into several areas, which is powered by semiconductor. Education is another area which will emerge very well using AI. It can have replacement of traditional teaching method, or it can have enhancement of traditional teaching methods. It can have customization of content, for example, based on AI. It can have immediate feedback system using AI, or keeps engaging actively the way gaming zones keep them active. It can keep students active or engagement active. In the same way, progress tracking, resource accessibility, adaptability. These are the multiple areas where AI can be implemented into the education and semiconductor can be actively deployed. The second major area which will emerge is defense, where many applications, in fact, all the applications of the defense will migrate from analog to digital or digitize, and from digital to AI-based systems. It has already started in communication domain. It will also continue into the integrated warfare, electronics, integrated warfare systems, which will run AI-based architecture on hardware and software. Many of us know, or if not know, that recent Middle East conflict had usage of AI by country A in a very heavy manner, but they were able to predict that where the movement is happening by the enemies or by the terrorists or attackers, and where are the vehicles moving, including planes from other side, where are the missiles being launched or it can be launched. So country A use missile prediction system using AI to detect missiles, possible threat of missile coming from Lebanon or other areas around that. And they accurately found out that there are 2,000 sites which can launch missile from northern Israel, and they immediately started defense movement or defense activity using AI. So this is one or two examples of defense, but it has more than 200 different scenarios feasible. And it is going to be like a chess style approach. Somebody puts one strategy in AI, the new strategy will emerge. The third strategy will emerge. The fourth strategy, new and new models will continue programming, training the model, and the user model will go more stabilized once it takes a decision. So defense is one of the major application. We have been already developing silicon chips for drone using AI application and doing active communication using AI on the drone. Now, when we design silicon chips, it also being impacted by the manufacturing technology. Right now, the whole silicon industry is here. We are developing chips or manufacturing chips using 10 nanometer, 7 nanometer, and 5 nanometer. Most of these chips are for data center, mobility, and AI ML application. Most of them. The older technology like 15 nanometer, 32 nanometer, 45 nanometer, they are being used for transportation industry like car, trucks, etc., etc. Now, the next generation silicon designs are starting at a nanotechnology. So after 5 nanometer, it's a 3 nanometer, 1 nanometer, and angstrom units. Again, here more and more AI applications using GPU, CPU, DPUs will be developed, and a lot of disruption will happen in healthcare, in defense, and in multiple areas of humanities because of this small size of the transistor entering into the nano area. It will allow more GPUs or more CPUs per die and high speed per die. So the more industry moves from 5 and 7 nanometer to 3 nanometer and 2 nanometer, more AI application will come out and will be implemented. So AI is strongly driving the semiconductor field, and semiconductor field is becoming major building block of AI. And that's the reason my session is addressing semiconductor and AI as a key component, because the semiconductor is a very, very key component for any AI implementation. So if I take a quick, sneak peek, then there are two areas where AI and semiconductor are very, very strongly executed. One is AI blocks are executed inside semiconductor, like DPU, GPU, processing engines, algorithms, mathematical formulas, DSPs, digital signal processors, neural network. Everything is implemented as a block inside the chip, and the chips are running parallelly. That means everything is inside chip. And the other segment is EDA tool, the electronic design tools or CAD tools used to design chips will have AI feature inbuilt. That means we can do functional verification using AI. This means we can do physical design using AI. So these are the two major area we are saying that AI and semiconductor will continue going like two vehicles on the one highway. Yeah, with that, I'll pause here and would like to give this slide as a last slide. If we see the 10 largest corporations in the world, market cap wise, Apple, Microsoft, Google, Amazon, followed by Tesla and Nvidias and all other here, right? First five or first eight are focusing strongly on AI. Of course, TSMC and UH will not follow AI because they are manufacturing houses. But out of 10, five are focusing on AI. These five are investing heavily on AI. And they are able to do it because of the semiconductor investment they have done, or they are still continuing to do that. So this is the very insightful data, and this data is also more important. If we club Microsoft, Apple, then their combined market cap is $6.14 trillion, which is larger than India's own BSE turnover. If we combine Microsoft, Apple, and Nvidia, it goes into about $10 trillion market cap, which overtakes China's $9 trillion market cap. This means the 10 companies can buy two countries. And hence, you can see the importance of AI in terms of economy, in terms of GDP, and in terms of semiconductor. So this is the reason all of these 10 companies are leading this market, because they have one fundamental difference called semiconductor. People have semiconductor, Microsoft has now semiconductor, Google have semiconductor, and others. And hence, the AI engine they are developing is going to lead the market. Anybody wants to develop AI, if they don't focus on the semiconductor, they will lag behind, because these five giants will eat away. So with this, I'll pause here for any questions, discussion topics.
Yes, all participants. Now there is a question answer. Raise your hand so the team will unmute you, or you can unmute yourself. We'll give.
Hello.
Hello. Yes.
Hello, sir. Good afternoon. Hello,
Yes.
am I audible?
Yes.
Yes, sir.
Okay, sir, as we know that we are actually AI is very much crucial in the coming days, in the days to come. So, what are the various challenges for the teacher to compete the AI model? That how it is basically challengeable for the teachers as well.
Good question. Number one, I have been in the technology industry for almost 25 years, right? So technology is going to be a key life component for everybody. And technology is changing every decade. A decade back, cloud was a hot word. Everybody was talking about cloud. Everybody was talking about IoT, right? So every 10 years, this technology cycle changes very differently. So when something is changing differently, the teaching system has to also change differently. That's the first, one of the first bullet I want to answer. And after 10 years, also you'll have a different situation. Number two, the way we used to use, people who are in their 40s or 50s, the way we use Google, exactly same way the next generation for the next 10 years or decade will use chat GPTs or AI. So AI will replace Google concept of search engine. So these are the behavioral changes happen. And we as a teachers or we as all, people need to be aware that if this is going to be the future, if this is going to be the building block of the future, nobody can stop it easily because it is going to be a future. So we have to adjust, align towards this only. The way we align during COVID on remote working, remote education, remote many things, and these online tools, whether it's a gaming tool or work tool or study tool. So AI being a future component, we have to make it as a part of framework in the education system for teachers. Number two, we have to make it part of curriculum or part of components in the curriculum. And number three is a part of project in the where as and where possible into the teaching system. And number five is already you are doing it. So you all teachers or learners are attending this kind of AI conference or seminar or FDP is a sign that the teaching fraternity is already doing learning for this future. So projects, projects, teaching curriculum, and accepting these is going to be a change process for all the learners or teachers. Exactly same I and we here in industry are doing. We have developed our own AI platform. We have developed our own chatbots within the organization. We have converted our intranet. We have converted our many framework AI base so that when our new employees or the next generation employees or Gen Z employees or anything else comes up, we don't feel fallback or we don't suffer productivity because of that. So this is my answer to you.
Thank you, sir. Thank you.
Yes. Any question? Hello, participants. Can you hear me?
Yes, sir. Yes, sir.
Okay. Okay. Yeah. Thanks. So Uh, Still, we'll open for 1 minute. If any participant is having any query, they may ask. Otherwise, we'll go for a short break and we'll start the third session. Okay. So, sir, let us take a one participants, one photograph screenshot with all participants and expert.
Sure.
Okay. Thank you very much. So, thank you, Nilesh sir, for the session. And again, we'll meet in valedictory at 7:30. You are heartily invited to attend the same. So,
Okay.
yes. So all participants, you are having a break of 10 minutes. We'll again log in at the time of 4:25. Thank you, sir. Thank you, Nilesh sir. Thank you.
Thank you all. Thank you.
Yeah. Okay. So 10 minutes break.
Thank you.